All right, my Ninja Warrior. So I am here with the highest weighted chapter of JEE Main 2025, that is going to be matrices and determinants. So you can clearly see the statistics on the screen that in January attempt there were 20 questions asked from matrices and determinants alone, and in April attempt the number is 21. And you all know that in January 10 question papers or 10 shifts you can say were held in January JEE Main 2024, and same goes with April, again 10 question papers. So out of 10 question papers, so you can clearly see that 20 questions approximately you can get. So you can expect two short questions from matrices and determinants, right? Two short. You might end up getting 3 questions also in some of your shifts. 2 questions, that means 8 marks, and 3 questions means 12 marks. So 8 to 12 marks alone from this particular chapter. And if I talk about the nature of this chapter now, then there is no such prerequisite required to study this chapter, because as you all know that calculus chapters are interlinked. Probability, if you have to study, you have to know permutation and combination and so on, right? But for matrices and determinant, there is no such prerequisite. You can just start away without even knowing any 11th chapter or any 12th chapter as well. Okay, and there are some hot topics which will lead you plus 4 marks. Let me just talk about it. So that is system of linear equation. You must be aware about that. Some of you must be aware about that as well. System of linear equations is definitely going to be there in JEE Main 2025 almost every shift. So plus 4 short marks you can get just by studying that topic. Okay, so that we are going to cover today, the questions of JEE Main 2024. But this session is only going to be about April attempt. For January attempt, we can you can see a similar video in the playlist. Okay, so let us quickly start with the very first question, and the question is here. So in the beginning, what we will do is we will start with the very basics of matrices and determinants. So there are a few questions which will only involve basics of matrices and determinants. Okay, so the very first question, let us see. Let A be a 3 cross 3 matrix of non-negative real elements such that this matrix equation holds true. Now the maximum value of determinant A is what we are looking for. Okay. So the reading of the question is very important everywhere. This question is very small. So you have to have a clear understanding of the question first. So based on this given equation, what we need to do is we need to optimize the value of determinant A. Okay. So let us just quickly use this equation. Let us quickly solve this equation to get the to extract the maximum information out of this equation. Are we ready for it? So suppose A is 3 cross 3, right? So let me just assume that matrix A is A1, A2, A3, B1, B2, B3, C1, C2, C3, right? This is your matrix A. Now, if I just plug in this matrix A into the given equation, what will I get? So we just need to simply, what we need to do is I'm just removing it and I am multiplying this with 1, 1, 1. Okay, let me just quickly do that. Let us multiply this this matrix with matrix 1, 1, 1, and what we are going to get is, so just multiply this 3 into this. What we are going to get 3, 3, 3. This is what we are going to get. So this is your A. This is what we have plugged in matrix A. Okay. Now let us quickly multiply. So this row 1 will get multiplied with column number 1. A1, A2, A3 will get multiplied with column number 1. What will you get is A1 plus A2 plus A3 will become 3. Okay. Similarly, B1 plus B2 plus B3 will also become 3, and C1 plus C2 plus C3 will also become 3, my dear students. All right. All right, system is actually shaking. Okay. All right. So now we are looking for determinant A. So using this matrix A, you can see on your screen, I will calculate the value of determinant A. So determinant A from this very matrix A will be equals to, let us expand this matrix row wise. Let's take matrix of the determinant and then expand it, okay? So A1, that is going to be B2C3 minus C2B3 minus, we are having A2 and we'll be having B1C3. So A2, we are expanding along row number 1. So A1 if I hide this, so B2C3 minus B3C2, correct? Then A2, so if I hide these two, so what will I get is B1C3 minus B3C1, correct? So B1C3 minus B1C3 minus B3C1, correct? And plus A3, and now A3 if I'm gonna hide, I'm gonna get this cross this. So B1C2 minus B2C1. Alright, B1C2 minus B2C1, correct? Now, this question is absolutely easy if you understand the logic behind it. So what is happening over here? Equation 1, equation 2, equation 3. 3 independent equations are given. Okay. Based on these 3 equations, I need to identify all 9 elements value. Yes. Now you must be wondering, ma'am, how come this is possible? I mean, for 3 unknowns, we need 3 equations, but here there are 9 unknowns. And you are asking us that for 9 unknowns, only 3 equations are given and you just predict the value of all 9 elements. Yes, we can do that because here we are not talking about the values extracting by normal method. Here what we are going to do is we will apply the concept of optimization or maximization. Okay. So, and one more condition, let's not forget, non-negative real elements. All the 9 elements are non-negative, first of all. So, they can be 0 and they can be positive, okay? So there are multiple options over here that all 3 elements become 1, right? If I just only talk about single equation, then we can apply the same logic in all 3 equations. 1, 1, 1. Or it can happen that 2, 1, 0 is also one of the options. Or 3, 0, 0 is also one of the options, right? Okay. I guess that, and there are obviously multiple options, but I have to maximize my determinant A. Now understand one thing, that determinant A, the very first term if you observe now, it is A1, B2, C3. What is so special about A1, B2, C3? Are you able to observe it? A1, B2, C3 is nothing but the diagonal elements of determinant A. So if I mark A1 as 3 from this equation, so I am marking this as 3, rest 2 becomes 0. And for this B2 also, I mark B2 as 3, rest 2 elements become 0. And same goes with C3, 3 and rest 2 element become 0. So what I'm trying to say is all the diagonal elements will become 3 in this matrix and rest of the elements will become 0. So this becomes a 3 identity. Right, 3 times identity. Then what will happen? Then 3 multiply 3 multiply 3, the very first term will become 27 and rest everything, because C2B3 everything is 0, because A2 is also 0, A3 is also 0 and these two are also 0. So determinant A will always be, because you know now the matrix will become what? Observe. So our determinant will become 3, 0, 0, 0, 3, 0, 0, 0, 3. Right? Now you just calculate the value of this determinant, 3 cube, that is 27. Right? And this is the maximum possible value of the determinant. If you just use any of the cases except this case, you will realize that you are not getting the maximum value. Right? So it is just the matter of observation. This question was matter of observation and optimization. Okay. All right. Let us move on to the next problem now. Okay. Question number 2. All right. The question number 2 is very easy because it uses the basic properties of minors and cofactors. Not even minors, just cofactors. Let us try to read it. Let alpha beta is non-zero. That means both alpha and beta are never 0. Okay. And so here we have matrix A and we are having matrix B as well. Okay, A and B. Now B, they are saying that there is a matrix B which is the matrix of cofactors of the elements of A. Okay, so first thing, which cofactor? B is cofactor of A. Cofactor matrix of A. Okay, all right, you know how to calculate cofactor matrix, right? Okay, so what we are going to do is, we have A matrix, so we can calculate that cofactor matrix as well, and then we are going to compare it with B. Okay, because it is given. So we can calculate the cofactor matrix and we can compare it with existing given cofactor matrix of A. Okay, and this way what we are going to do is, we are going to extract or get the value of alpha and beta. Once we get alpha and beta, just tell me, determinant A and determinant B calculation both are very easy. Yes or no? Okay, all right. So first thing what we are going to do is, let us calculate the cofactor of A11. Okay, cofactor of this element. So cofactor of A11, let's calculate, and that is going to be 3 alpha, correct? Okay, cofactor of A11, for that we need to hide this. 2 alpha square minus alpha beta, can you see? 2 alpha square minus alpha beta, and that is going to be 3 alpha. And actually, honestly, this is not at all helping me in calculation of alpha or beta, right? I need something which will either have single variable, because alpha and beta using one equation I cannot calculate. So I will look for that cofactor. I have 9 options, and I need only 2 equations to solve for alpha and beta. I'm not here to equate every cofactor. Are you getting my point? So what I'm going to do is, I'm going to find the minimum effort cofactor. Okay, let's do that now. A12. So 2 alpha square plus beta square. Again, alpha and beta both are coming. Not good for us. Okay. Now A13 ka cofactor, let's find. So alpha square plus, again beta is involved. See, alpha square plus alpha beta, right? Beta is getting involved over here. And now we are going to calculate cofactor of, hopefully, A12. Hopefully it will have single variable. Let's sort it out. So we are going to calculate A21. This is A21, right? So 2 alpha square minus 3 alpha. Can you see? 2 alpha square minus 3 alpha. So cofactor of A21 is 2 alpha square minus 3 alpha, correct? So 2 alpha square minus 3 alpha, and with which sign? Sign also we have to take care of. Cofactor of A21 will be negative, because 2 plus 1 is 3. This position will hold a negative sign also. And now the cofactor of this is minus alpha, right? So we just need to equate, minus minus cancel. So 2 alpha square is equals to 4 alpha, correct? Alpha and alpha we can easily cancel out, because alpha is never 0. So from here alpha is coming 2, and now what we can do is, we can just plug in this value of alpha over here. Let's do that. The moment you plug in the value of alpha, what will it become? So 2 square. All right, before actually doing that, now again 1 alpha can be cancelled out. So 2 2s are 4 now, minus beta equals to 3. So from here beta is coming out as 1. Okay. All right, beta 1, alpha 2. Now what are we wondering? What are we waiting for? Okay, so what we can do is, we can just calculate determinant AB. This is what the question is asking. That is going to be determinant A, determinant B. Now there are 2 ways to go about it. First way is, just calculate determinant A, calculate determinant B, and that's it. Okay. So let's do that. Determinant A, so beta alpha 3. Beta is 1, alpha is 2, 3. right? We are calculating determinant A. Beta alpha 3, alpha beta, so 2, 2, 1. Then we are having minus 1, 2 and 4. Minus 1, 2 and 4. So we have just plugged in the value of alpha and beta, calculating this. So this is going to become 1, 4 2s are 8 minus 2, 6 minus 2. And then we are having 4 2s are 8 plus 1, 9 plus 3 times. We are having 2 2s are 4 plus 2, so 6. Okay, correct. 6 minus 18 plus 18 will give you 6 as the value of determinant A. Okay. Similarly, if you calculate determinant B, okay, what will that give? 3 alpha minus 9, 3 alpha. Okay. So 3 alpha, so 3 alpha minus 9 and 3 alpha. 3 alpha, correct? Then we have minus alpha 7 minus 2 alpha. So minus 2, 7 minus 2 alpha. So that is going to be 4. All right. Yes. Then we have minus 2 alpha, 5 minus 2 beta. So minus 4, 5 and minus 2. Correct. Now what we can do is from the very first, you can see that I have written it like that only. From the very first, let's say, row, you can get 3 common. Right now you can expand. So this is going to be 3. And now you can expand. So let me just erase it. This is your, basically if you take 3 common now, what will you get? Tell me. So 3 alpha, so 2 minus 3 and 2. Correct? Let me just check one time. Okay, so 3 is gone, minus 3. So 2 minus 3 and 2. Correct. Now let us expand it. Okay, so 2 minus 14 plus 20. Correct. Plus 3. Then we are having 4 minus 16. Plus 2, last thing. And we are having minus 10 plus 28. Minus 10 plus 28. Correct. Now we are having 3. So this is 2 and 6 plus 3 and minus 3 into 12. And this is 2 into minus 18. So can you see these two are, sorry, this is plus. 18 2s are 36. These two are quickly getting cancelled out and we are having 6 into 6. So determinant B is 6 square. So now the final answer. All right. Okay, so final answer of this question is 6 into 6 square. That is going to be 36 into 6. That is, so 6 cube basically, 216. And here we go. Option 1 is absolutely right. Okay. Now to calculate this also, now if you want to like stay away from determinant B. So this is your method number 1. Calculation of determinant B. There is another method also for calculating determinant B. Okay. So you know that determinant, you know that B is nothing but cofactor of A. Right. So can I just use this very fact and calculate determinant B in terms of determinant A? Yes, we can do that. So you all know for that we will need some properties. So you know already that adjoint of A data, very important property, right? That we are going to use in this session. I'm going to revise it. Adjoint of A determinant is nothing but determinant A raised to power n minus 1. Okay. In this particular case, n is the order which is 3. So adjoint of A will become what? Determinant A square. Right? Now one thing, tell me that what is adjoint? How do you calculate adjoint? So adjoint of A is nothing but transpose of your cofactor matrix. Right? So now if I take transpose of your cofactor matrix, and what is your cofactor matrix? Cofactor B is your cofactor matrix, right? So adjoint of A in this case is B transpose. Now take determinant, both the sides. So determinant adjoint A is nothing but determinant B transpose. And one more property I would like to introduce. Determinant B transpose is determinant B. Just try understanding properties, okay? And this is going to give you determinant B. Determinant B is determinant adjoint A, which we just calculated. That is going to be determinant adjoint A square, right? So determinant B will be nothing but adjoint A square. So determinant A, so you have to calculate, that is 6. And determinant B is 6 square, which we've already calculated. So this is it. 216 is bingo answer of this question. All right. Now let us, without wasting any time, let us move on to the next problem. Now this question is based on the very basic property of matrices. Okay, very basic, like simple matrix multiplication, the understanding of adjoint, that's it. Okay, and the pattern based question. So very easy, I will call it as. And also let's not forget, I always tell that after doing the problems, identify the question into alpha, beta and gamma. Right? Alpha, beta and gamma. Okay. Alpha are those questions which will take very less of your time. Okay. So alpha category are such questions which can be done in less than 1 minute. So they are like not heavy, lighter on calculation, and the conceptual wise is also you have done those type of problems so that you don't have to think a lot to do such questions. Beta is again doable questions, but it will take greater than 1 minute because sometimes you feel that by looking the question that the calculations are becoming heavier. And gamma are such type of questions which will actually drain you, exhaust you, and it will not give you answer, or maybe you are like not onboarded with that particular concept, you don't even have studied that concept. So gamma is that type of concept. So these three categories you have to define, that will help you in actual JEE Main examination. And this strategy you have to apply in mock test as well. What is this strategy? So you have to scan and divide the complete paper in 3 categories, right? And that category is alpha, beta and gamma. The first 15 minutes are focused on alpha category questions, which are 6 to 8 questions in every paper. Now beta and gamma category are like, it is dependent on the students, right? Sometimes it is more or less same, but it feels that sometimes I feel binomial question, so I found it very difficult. But you guys say, okay, no ma'am, binomial to I love. I to do it binomial in like quickly in fraction of a second. So it is subjective also, but you have to build your strategy. So now let us rate every question. I feel you can tell your thoughts also in the comment section. So question number 1, I feel that so that was actually, this thing was thoughtful. So sometimes you might not be sure that exactly at 3 we are going to get the maximum value. So thoughtful, because of the thoughtful nature, it is between alpha and beta, somewhat alpha, somewhat beta. Okay, so yes. Okay, and this alpha question, definitely. Okay, alpha question, yeah, somewhat a little bit greater than alpha because it takes a lot of your calculation time, but it is not at all that heavy on calculations as well. All right, yes. Now the third question. Okay, so let's do it and then talk about whether it is easy, medium or difficult, alpha, beta or gamma. Okay, so now we are having a matrix which is having a matrix, right? And we are having B is equals to identity matrix plus adjoint A plus okay. So to get, now B is like sum of 11 different matrices. Yes, okay, all right. And we are looking for sum of all the elements of matrix B. There are high chances that this question is going to be turned out as a pattern based question. For that, let me just write down A matrix 1 2 0 1 1 2 0 1. Okay, now what we have to calculate is adjoint A square and so on, right? Identity to we know. Now adjoint A, there is a shortcut to calculate adjoint A, ninja technique, do you know? The shortcut to calculate adjoint A of a 2 cross 2. This shortcut is for 2 cross 2. Okay. Suppose A, B, C, D. Okay. There is this matrix A, B, C, D, C matrix, let's say. And adjoint C you have to calculate. C le lete hain. Adjoint C you have to calculate. So you have to interchange the diagonal elements. So can you see A and D here? So I am going to interchange A and D. Right? So interchange the position of diagonal elements. And now the remaining two elements B and C, you just have to change the sign. So this is minus B, this is minus C. That's it. Okay. Alright, so let us do that right here. So 1 and 1 if you interchange, there will be no change. Same. 2 and 0, this and this. So you have to interchange the sign. Minus 2 and minus 0 will again 0. So this is your adjoint of A. Now calculate adjoint A square. Are we ready for it? 1 minus 2, 0 and 1. Again, 1 minus 2, 0 and 1. Let's calculate. Row 1 and column 1. Okay, row 1 and column 1. Can I just use highlighter? No. Do we have an highlighter? Okay, maybe not. Chalo, theek hai, koi baat nahi. So I'm going to multiply this and this. Okay, so 1 and 1 ones are 1, minus 2 into 0. So only 1. Then row 1 and column 2. So minus 2 and plus 2. Can you see? Minus 2 and, okay, no, minus 2 and minus 2. Minus 2 and minus 2. So minus 4. Then now row 2 and column 1. So 0 and 0. So 0. Correct? And finally row 2 column 2. So this is going to become 0 and 1. Okay, this is your adjoint A square. Some pattern is getting formed. So you can see this is your adjoint of A. And this is your adjoint of A square. Clearly that every element is same. Just this is minus 2. This is minus 4. Let's see. Adjoint A cube also if you calculate. Then you will get to know. So 1 minus 4, 0, 1. This is adjoint A square. And then adjoint A, right? So this is your adjoint A square and this is your adjoint A, correct? This will give you adjoint A cube, right? Again, row 1, column 1. So 1 and 0. So 1, okay, clear. I am hoping that this is going to be same. You just check it out. Oh, I am concerned about this element, okay? So this is this element I am going to get by row 1 and column number 2. So 1 into minus 2, minus 4. So minus 6 I am going to get. Okay. Now I am getting it. Now I am getting it. Just tell me. When we are having adjoint of minus 2. So this is minus 2 into 1. Minus 2 into 2. Minus 2 into 3. Adjoint A power 4 will have minus 2 into 4. Rest everything will remain same. Okay, minus 2 into 5, minus 2 into 6. Okay. All right. B. B is your identity. 1, 0, 0, 1. Okay. Adjoint A. Now, adjoint A, we have already calculated. Let me just copy and paste. 1 minus 2, 0, 1. Then we are having 1 minus 4, 0, 1. This is adjoint A square. Adjoint A cube is this. And last, adjoint A raised to power 10 will give you what? 1, 0, 1. And if it, so this is minus 2 into 10. So minus 20. Correct? Now you just, you have like 11 matrices. Just find the sum of all the elements. So I can see that this is 1, this is 1. So for diagonal elements, let's talk about the diagonal. Sum will be equals to what? So for diagonal we are having 2 and we are having 2 and we are having 2 and all the way up to here also I am having 2. How many 2 you will see? How many matrices in the beginning? No, 10 nahi hai, it is 11. So 11 times. And just that I have to understand that this element है ना? तो it starts with -2, -4 and all the way up to -20. That's it. Now this is 2 into 11 plus, if you take -2 common, 1 plus 2 plus 3 all the way up to 10. So this is 10 into 11 by 2, n plus 1 by 2, minus 2 and 22. So this is going to become 22 minus 11 times, right? 22 minus 110. Yes. So it will give you what? Minus 88 is the final answer of this question, which is matching with option 2 or option B. Alright, so this is how your pattern based question looks like. But you have to be very sure, like the pattern cannot be forced pattern. It will be visible to you. If it is not visible to you, then you have to like do some hard work. Okay. Are we ready for the next question, my dear students? Yes? Chalo, let's start. All right. So I will mark the last question as alpha question. Alpha question. What do you think? Let me know your thoughts in comment section. All right. Okay. If the sum of the diagonal elements of A13 is 3 raised to power n, then n is equal to which value is what we need to figure out. Okay. For that I need to have A raised to power 13. So let's hope that A raised to power 13 we don't have to calculate all the way A raised to power 13. Rather, what we need to do is we need to identify some pattern. But if we do not get any pattern, we have to do the hard work, labor work. Okay. So A is your this. Let us go on the next page. 2 minus 1, 1, 1. 2 minus 1, 1, 1. Right? This is your A. What is A square? 2 minus 1, 1, 1 and 2 minus 1, 1, 1. Let us calculate A square. So again, it is going to become what? Yes. Row 1, column 1. 4 and minus 1 will give you 3. Row 1, column 2. So minus 2 and minus 1, so minus 3. Row 2, column 1. So this is going to give you 3. And finally, row 2, column 2 will give you 0. Okay, all right. So this is going to become 3. 1 minus 1, 1, 0. This is your A square. I am interested in A raised to power 13 and that too diagonal elements of A raised to power 13. So without calculating A raised to power 3, why not calculate A raised to power 4? So that is A square and A square. So this will give you 3. 1 minus 1, 1, 0. It is obviously better to take 3 common because now you have to deal with only like, if you deal with multiple of 3, the calculation will be tougher, right? Again, one more 3. 1 minus 1, 1, 0. So this is going to be 3 square. And now you just have to do this. Row 1, column 1. So 1 and minus 1. So this is 0. Okay. Till now I have not seen any pattern is getting formed. Okay. Okay. So row 1, column 1 is 0. Row 1, right? Row 1, column 2. Minus 1. That's it. Correct? So minus 1. Now row 2, column 1. So 1 and 0. 1. And row 2, column 2 is minus 1. Okay. Again, A raised to power 4 we are getting now same. A raised to power 8 we need to do by multiplying A raised to power 4 with itself. So 3 square 0 minus 1 1 minus 1. Correct. 3 square 0 minus 1 1 minus 1. Correct. So this is 3 raised to power 4. And now again we have to do the same thing. Row 1 and column 1. So 0 0. Okay. And then minus 1. So minus 1. Okay. Row 1, column 2. So this is 0 and then plus 1. Okay. Now row 2, column 1. So 0 and minus 1. Okay, and row 2 and column 2 will give you -1 and +1, so 0. We just feel that 0 is rotating here and there, right? That's what we feel, but we are very close. And until now, any pattern, if you see a square, 0 was here, then 0 was here, then 0 is back here. Okay, so basically some rotation is going on, but still no pattern. Now a raised to power 12 is what? A raised to power 8, a raised to power 4, correct? A raised to power 8 we have calculated 3 raised to power 4 minus 1 1 minus 1 0, correct? A raised to power 4 is 3 square, 0 minus 1 1 minus 1, correct? So this is 3 raised to power 6. Okay, and now you have to row 1 and column 1, right? Row 1 and column 1, so 0 and 1, so 1. Okay, all right, so this is 1. Then we have row 1 and column 2, so +1 -1, 0 is here. Okay, then we are having row 2 and column 1. I know it is irritating. So this is 0 and 0. Okay, 0. All right, ठीक है. Finally, row 2 and this. So plus, okay. A raised to power 12 is 3 raised to power 6 identity matrix. Now we are looking for A raised to power 13 and that too diagonal elements. Okay. So A raised to power 12 into A will give you, right? So 3 raised to power 6 identity matrix. Sorry, identity को let's write I and A. So this is going to be 3 raised to power 6 A. 3 raised to power 6 A is this 2 minus 1 1 1, right? So if you multiply, because you are looking for sum of diagonal elements, so 2 dot 3 raised to power 6 and 3 raised to power 6 and minus 3 raised to power 6, 3 raised to power 6. Do not make any mistake in last step. Now tell me, sum of diagonal they are giving is 3 raised to power n. Sum of diagonal will be this plus this. So 2 dot 3 raised to power 6 plus 3 raised to power 6 is equals to 3 raised to power n. That is going to be sum of diagonal. Sum of diagonal elements, right? And that is going to be 3 power 7 is equals to 3 raised to power n. N is coming out as 7, and final answer of this particular question is, there you go, 7, right? I would say that again, I will feel that alpha question, okay, because you just need how many matrix multiplication? 2 cross 2 matrix multiplication is easier than 3 cross 3, right? So you need one matrix multiplication over here, one more 2, one more 3, and 4 matrix multiplication. 20 seconds it will hardly take to see one matrix multiplication. So again, less than 1 minute, approximately 1 minute, this question can be done. Okay. All right. Now, okay. So we are having one question based on properties of determinants. Yes. So here properties of determinants we are going to use. Basic properties, right? Just the row and column properties, determinants. Let's see what's so special. So this is actually very popular type of a question, wherein so this year I have taken this in row series. I hope that you know about row series. So this year this question I have taken in row series, but if I talk about like previous year or previous years where this question was not in the picture, I used to always take this same type of question in my notes, like in my proper lectures. So what I'm trying to tell you is this is a popular type of a question. This is not a new type of a question. So basically you have to understand that there are two categories of alpha question. Number one, the question itself is easy. Number two, that the market value of that question you have to understand, right? So if it is in every institute's mock test, if it is there in every teacher's notes, so that problem is already like viral. The problem is not new. You have done it so many times. So I will mark it as alpha, right? Because I am thinking from the overall perspective. So many students have done this problem so many times, okay? Because of the mocks or because of teacher's notes, or you can find this question on YouTube as well. Okay, chalo. So this is how the nature of this question. Okay, all right. So how to tackle this? Let me just tell you how to approach this question. So alpha is not equals to a. Okay. This determinant is 0. This determinant is given as 0, and we are here to look for the value of this expression. What is like the special thing about this is here this expression is having some terms, alpha minus a, beta minus b, and gamma minus c. These terms you have to create in this determinant itself. If you think that I will open this determinant and all of a sudden I will get this expression, this is not going to happen. You will be stuck. So before expanding this determinant, be careful. Okay, do not even think of. Rather than that, in the determinant itself, can you create alpha minus a, beta minus b, gamma minus c? Can you do that? So very simple, alpha minus a you will create if you are actually able to do the row operation. R1 goes to R1 minus either R2 or R3. Okay, let's say R3. So alpha minus a, can you see R1 minus R3 will give you alpha minus a, right? B minus B will become 0 and C minus gamma. So what I will do is I will simultaneously do two row operations. Why? Because if you do R1 minus R3, na, so can you see alpha minus A is getting created, C minus gamma, that means this is also getting created, but beta minus B is not getting created. So for that you do have to do one more row operation. So whenever you apply two simultaneous operation, very important, understand that if you have to do two operations, then you just keep that in mind that one row I have to keep unchanged. You can say that I am keeping R2 unchanged, that is also fine. So R2 goes to R2 minus R3. So observe my row operation. I am changing R1 and R2. That is the first thing. With the help of obviously R1 and R2, right? That is the property. But with another row that is going to be R3, that I will keep unchanged, right? So always apply the operation. Always think about R1 you are changing and unchanged. So in any operation, you have to keep one changing and one unchanged one. So R1 you are changing anyway, R3 you have to keep intact. So both the row operations using R3 I am doing. I hope that what I am saying is clear, okay? Just that. Okay, now we just need to apply it. You are done. The moment you apply this row operation, you are done, okay? Let's do that. So it is going to become R1 minus R3, na? So alpha minus A will be row number 1, B minus B will be 0, C minus gamma, row number 1. What about row number 2? So A minus A will be 0, this is beta minus B, this is C minus gamma again, and this is A, B, gamma. Now there are two options. If you want to expand it, do it right away. Okay? And yeah, or what you can do is, because you already know alpha minus A is in denominator, so you can take three things common. Okay? That is alpha minus A, beta minus B, gamma minus C from this very determinant. Or you can open it right here. Okay, let's do that. Let's expand. Alpha minus A outside, then we have beta minus B times gamma minus B, C minus gamma. Then 0 is gone, plus C minus gamma is outside, and you are having, this is gone, right? Again, only, okay, so this is 0 and minus A times beta minus B. So minus A, beta minus B, that is equals to 0. Now obviously, you don't have to multiply it, okay? You want to keep these things intact. If you multiply it, it will become vanish. And then it will be same as the random opening of the determinant. What you have to do is, you want alpha minus A, beta minus B, gamma minus C in the denominator. So why not divide whole equation by alpha minus A, beta minus B, and gamma minus C. Let's do that. Okay, multiplication, 3 factors. But before that, let us just first simplify it. Okay, at least we can just multiply it. So this is gamma, alpha minus A, beta minus B, correct? Minus. B times, this is C minus gamma and alpha minus A, correct? Minus, this is A times C minus gamma and beta minus B, this is equals to 0, correct? One thing is just that I need to just make some adjustment because there is gamma minus C clearly and this is C minus gamma. So why not do one thing, I will apply plus sign over here and I will reverse the sign over here. This is gamma minus C. Can I just do that? Gamma minus C, gamma minus C. Now everything is in plus. Now on the last master stroke, divide everything by alpha minus A, beta minus B and gamma minus C. If you divide, what will you get? Tell me the final answer. So this is gamma and alpha minus A, beta minus B will be get cancelled out. So this is gamma upon gamma minus C. Can you see the third term you are creating already? From the second term, if you divide it, gamma minus C is gone, alpha minus A is gone. So B upon B minus beta. B upon B minus beta, and last term will be A, then gamma minus C, beta minus B is gone. So A upon alpha minus A, and this is 0. So the final answer of this question is C option, third option, that is 0. Okay. All right. So just understand that this question, I would say, if you do not know it, sometimes it might be confusing or difficult that how to do it. But I told you now, if now you know this type of question. Now can you just tell me, after knowing this, if you get the same question, exact same question, sometimes the answer is 0, sometimes the answer is 1, sometimes the answer is -1. Okay, I'll buy a little bit here and there variation. So just tell me one thing. The answer of whether it is alpha or beta, just tell me, because just two row operations, set method, it is set two row operations, then open it and divide by these three factors. That's the same algorithm. It is rotated in market. I already, so this is an alpha question, I feel. Okay. All right. Now there are another category we are entering in, wherein you will see that properties of adjoint, properties of determinant, properties of inverse will be involving. Okay. So you can see there were multiple questions in 2024 April attempt asked from this topic. Right? Whereas just see determinant of, adjoint of, now so many things, right? Let's count how many questions, similar questions were there. First question on this property, second question, similar type of, third question, right? Fourth question, okay, and that's it, fourth question. After that, we are having system of linear equation, okay? 4 questions alone from this same topic. So before that, we need to do some preparation. Let me just go back. Let me just go back and all right. And let me just list down the all possible properties which we are going to use. The very first property is determinant of adjoint of A. Okay, that is going to be determinant A raised to power n minus 1, where n is the order. Usually it is 3. So if order is 3, just keep in mind, write A square if n is equals to 3. You know, keep this in mind. Second property is this very important property, adjoint of KA. Remember, I am not saying that determinant is here. This is different. What I'm saying is simply when you see adjoint of KA, for example, adjoint of 3A, adjoint of 2A. So this K has to come out and we need to pay the price for this K, and that price would be n minus 1 adjoint of A. Again, if I talk about if n is 3, so that is going to be again K square adjoint A. Correct? Okay. Now third property, which is very important, that is again determinant of KA. Now again, same thing. K, I have to take it out. I have to pay the price, and this time I have to pay the maximum possible price. So K raised to power n determinant A. So this is for n equals to 3, right? For n is equals to 3, k cube determinant A. Third property. Fourth property is determinant of A inverse, right? And this is 1 upon determinant A. Fifth, very easy property, A transpose ka determinant is determinant A. And now I will extend the very first and important property for generalization. Okay, this is important. Whenever you see multiple adjoints, like two adjoints, suppose. So adjoint of A is what? Determinant A raised to power n minus 1. So this is determinant A raised to power n minus 1 square. Okay. And if you see determine adjoint of A 3 times, that is going to be determinant A n minus 1 cube. Okay, so this time n minus 1 power 1 because one adjoint was written. Adjoint 2 were written, so n minus 1 square. If 4 adjoint is written or n adjoint is written, now you tell me. N times. Okay. So that is going to be what? Determinant A n minus 1 raised to power n. Okay. So suppose k times, because I don't want to overlap, k times, so n minus 1 raised to power k. So these are the 5 very important properties. Okay. We are going to use first, second and third properties very extensively. And if we came across any more properties in the flow, I will write it over here. But this, you cannot at all skip these properties. Okay. Chalo, let's start with the very first question. A, they are giving in the matrix form where I can see alpha is missing. So the whole question is obviously about calculation of alpha. Okay. Calculation of alpha by using this equation. And also what in the end, what we need to figure out is determinant A square. So determinant A or determinant A square, we will be able to calculate once I know this alpha. Okay. So we are very much after alpha. That's it. Alpha will lead us to the final answer. Now determinant of adjoint, let us decode this. Let's do that. Determinant of adjoint of 2A minus A transpose. Okay. One more adjoint, we are seeing adjoint of A minus 2A transpose. Determinant close 2 raised to power 8. Okay. All right. Now one more property I'm having, sixth property, determinant AB, very easy property. You must have, you all must know it. Determinant AB is determinant A, determinant B. That's it. You know this property, right? So again, can you see, that means determinant of multiplication of two matrices. So this is matrix number 1, this is matrix number 2. Product of two different matrices you can see. So if you can separate them out, so this is adjoint of 2A minus A transpose. And again one more adjoint of A minus 2A transpose is going to be 2 raised to power 8. Clear? Now which property I'm going to use? The first property used, properties used. Line wise sequentially I'm writing. Properties used. First property, determinant AB is determinant A, determinant B. Second property is determinant adjoint A is determinant A square for a 3 cross 3 matrix, right? And this is a 3 cross 3. So adjoint 2A minus, so this is also 3 cross 3, right? So let us just quickly apply this property. So adjoint A is determinant A square. So adjoint 2A minus A transpose is determinant of this square. And again same property, determinant of this square, that is 2 raised to power 8. Okay. Alright, so overall square I can do now. What I can do is this overall square, I can apply overall square, right? So this is actually 2A minus A transpose, A minus 2A transpose, and now I want to remove this square from the left hand side and apply it on the right hand side. Square root, taking square root both the sides. Plus minus 2 raised to power 4. Yes or no? Okay. One more property I'm going to use, because can you just see here that this is 2A minus A transpose, this is A minus 2A transpose. So these two are transpose of each other, right? So if I just say that, if I just write that take 2A minus A transpose whole transpose, you know the formula? Just apply the individual transpose, right? So this is 2A transpose minus A transpose transpose. So A transpose transpose will become, so this is 2A transpose minus A. That's it. Okay, okay. All right. So 2A transpose whole transpose is nothing but, so this, you're getting this actually. Okay. So, but there is actually, if you see 2A transpose minus A, this is A minus 2A transpose. So you have to take minus sign common from this, right? And this is not at all a modulus. This is a like determinant, proper determinant, okay? So again, determinant of 2A minus A transpose, correct? And this, if I take minus sign common, so this is minus 1 common. And this is A minus, sorry, this will become what? 2A minus A trans. If you take minus 2A transpose minus A, just minus sign I have taken common, nothing else. This is plus minus 2 raised to power 4. Now just tell me one thing, this minus is common. So the third property which I'm going to use is that determinant Ka. This K has to come out, it should become what? Cube, because order is 3 for n equals to 3. So minus 1 has to come out of determinant, so minus 1 cube. So this is actually minus of 2A minus A transpose, 2A transpose minus A, and this is going to be plus minus 2 raised to power 4. This minus sign, if you shift it over here, it will make zero difference. So this minus, if you shift, this will actually become minus plus 2 raised to power 4. Again, same thing. So this is 2A minus A transpose, 2A transpose minus A. Now, can you see? I already told you, if you take this and take transpose, you are going to get this. So these two are transpose of each other. Transpose of each other, yes or no? So, but in determinant, I have already told you, let's just go back. A transpose is A. If both are transpose of each other, you just pick any one and just write it like that. So this will actually become 2A minus A transpose whole square, and this is plus minus 2 raised to power 4. Yes or no? Let us just do it on the next slide. 2A minus A transpose whole square is plus minus 2 raised to power 4. Okay. Just tell me. So this is 2 raised to power 4 or minus 2 raised to power 4. Obviously, squared quantity cannot be negative. So that means 2A minus A transpose whole square is 2 raised to power 4. Square will go towards the right hand side. You will going to remove it. And you're going to get 2 raised to power plus minus 2 raised to power 2. Plus minus 2 raised to power 2. That is plus minus 4. So determinant 2A minus A transpose you are saying is plus minus 4. Okay. So you have to take two cases, but clearly alpha is a positive number. So now you have to like match this. You have got 2A minus A transpose is equals to plus minus 4. So 2A minus A transpose is what we need to calculate. So 2A, first of all, so double of this A. So 2, 4, 2 alpha, correct? 2, 4, 2 alpha, first row. Then 2, 0, 2, correct? Then we are having 0 to 4 minus A transpose. So 1 to alpha but placed in row wise. Then 1, 0, 1 is row 2 but I'm going to place it in column 1. And this is going to be 0, 1, 2. Now just subtract it. So 2 minus 1 is 1, 3, 2 alpha, 0, okay, then 0 and 1. Now we are having minus alpha, 1 and 2. So this determinant we have to calculate. Let's do that. Let's expand through column number 1. Okay, so 2A minus A transpose will become what? Tell me. So 1 and minus 1. So this is minus 1, correct? And okay. So minus 1 and then minus alpha 3, that's it. 3, okay. So this is what it is, right? So minus 1 minus alpha 3 is either 4. Minus 1 minus alpha 3 is either minus 4. Okay, let us solve it out. So from here, alpha will be negative, which will be rejected. And here alpha will be positive clearly. And so 3 alpha is equals to 3, alpha is equals to 1. So correct answer of this question is option B, 1. Okay. Somewhere between alpha and, because alpha and beta they are using. So nature of the question is somewhere between alpha and beta. Okay. All right. Yes. Shall we move on to our next problem? Are we ready for it? Okay. All right. Let us read this question out. Okay. Chalo. Let's do it. A and B be two square matrices of order 3 such that determinant A is equals to 3. Determinant B is 2, and then this whole determinant we have to calculate. So again, what we are going to use is properties, right? So I can see how many determinants you can see over here inside the single, how many matrices you can see inside the single determinant. 1, A transpose, then we are having A, then we are having this whole, the total 3, 4, okay, 5, 6 and 7. Okay, so first property which we are going to use is determinant AB is determinant A, determinant B, right? So just separate every 7 determinants. So this will be product of 7 determinants. A transpose, then A, then now we have to be careful, adjoint 2A. Okay, so this inverse is over this bracket. So adjoint 2A and then there is inverse. That's it. Then adjoint 4B. Okay. Then we have adjoint AB. Again, adjoint AB. Inverse is not on AB, but the inverse is over here. Then we have A and A transpose. The first very simple thing, second property which we are going to use is determinant A is equals to determinant A transpose. Second property. Okay. So this and this all 4 determinant will become determinant A raised to power 4. Okay. And now we are left with only 3 determinants. So we just have to solve 1, 2 and 3. Out of which these two, like the inverse ones, this and this, are having actually inverse on the whole matrix. So here we are going to use the property determinant of A inverse is 1 by determinant A. So these two right away can be taken care of. So what we can do is, this is 1 upon adjoint of 2A, so that we can get rid of the inverse. Understand, this inverse is not on 2A. If it was on 2A, then things would be pretty different, right? So right now think this as a alone matrix. So this is basically, if you put it at C, so this will actually become what? Determinant of C inverse. So you're writing 1 upon determinant C. And now again, if you put the value of C, so adjoint of 2A inverse you've got rid of, like that. Same goes with this. Okay. All right, and this is, so multiply, and now this is adjoint of 4B, correct? Again, the same, inverse is here, so upon adjoint of AB, determinant is here, that's it. So let's rewrite it formally, finally. So determinant A raised to power 4, determinant adjoint of 4B is here, upon determinant adjoint of 2A, determinant adjoint of AB. Correct? From here, what we can do is, we can use that very important property, adjoint of anything, any determinant is equals to what? That determinant raised to power n minus 1 basically, and for order 3 that determinant ka square for n equals to 3. Remember I told you. Now This is 2 square matrix. Okay, square matrix. Please understand. No. Square matrix. So we can't use it, है ना? So we need to check the order, then act accordingly. If it is a square matrix, n equals to 2, so adjoint anything will become what? Determinant. Oops, square matrix of order 3. So order 3, yes, 3 now. So again, yeah, sorry. Square. So determinant of adjoint of anything is determinant that ka square. Okay, so very easy. So this is determinant a raised to power 4, copy pasted. Now adjoint of anything. So 4b is also order 3. So this is 4b square upon, again, this is a, right? So determinant 2a square. This is determinant ab square. Okay. Now the very fifth property we are going to use, the fifth property over here is determinant of ka. Remember, we have to pay the price if we want to like get this k out, and that should be maximum one. The price should be maximum. So k cube in this case, k cube determinant a, right? So now if I have to take this 4 out, take this 2 out of determinant, what we have to do is, so this is actually determinant a raised to power 4. This 4 if you take out, that is going to be 4 cube. Okay. So determinant 4b, this square is already there. Please do not make this mistake. So many of students make this mistake. So this is 4. Let me just write it over here. Okay. Determinant a raised to power 4. This 4 you have to take it out, right? Out of determinant. So square is already there. 4 if you take out of determinant, it will be determinant b. Square is already there, right? 4 will come out and it will become cube. So most of the students do this mistake. If we take 4 out, they will write 4 cube. But there is one more square over here. So 4 cube and square. 4 raised to power 6 will be there. Please take care. And this is again 2 cube and square. So 2 cube and determinant a, then whole square. Correct? This will be determinant a square, determinant b square. Okay. So finally, this is determinant a raised to power 4. Then we have 4 raised to power 6. Then we have determinant b square upon 2 raised to power 6, determinant a square, determinant a square, determinant b square. Determinant b square gone, determinant, okay, can you see that we don't even know determinant a and determinant b? We are having right here 2 raised to power 12 upon 2 raised to power 6 is the right answer, which is nothing but 2 raised to power 6. That is going to be 64 as the correct answer. So option A is absolutely right. Okay, somewhat I have to, if you know the properties nicely, if you have done enough practice, then this question would be a cakewalk for you. But if you have not done, then this question could go in beta category. So to place this in alpha category, you have to maximize your alpha questions. Suppose if you find 10 alpha questions in your JEE Main 2025, 10 alpha questions, that means 10 easy questions. So 40 marks straight in your pocket within like first 15 to 20 minutes of mathematics section. Great. Out of the world. Okay. Again, another type of a question, but this is slightly different. So, square matrix of order 3. Always check the order first, okay, so that you be alert. So now, because we have already have the formulas in order 3 format, I have told you. Determinant A, they are saying is 3, okay. They are only talking about determinant A, and using determinant A value, we need to calculate the left hand side so that we get m and n finally, and then we are looking for m plus 2n. Okay, all right, chalo, let's do it. A is a square matrix of order 3 such that, yes. So now determinant of adjoint of -4, adjoint of -3, adjoint of, oh my god, so there are actually loop happening over here. There is only one determinant. Unlike previous question, there were multiple matrices multiplied together and written inside the determinant. Here, This is the single matrices, single matrix. -4 adjoint, -3 adjoint, 3 adjoint. Okay. And 2A. So inverse is on 2A this time. Okay, inverse is on 2A this time. -1. So this bracket is having the -1. Bracket close. One more bracket close. One more. So many bracket close. Anyway, determinant close then. This is 2 raised to power m, 3 raised to power n. This is slightly different. If I tell you one shortcut for this method, with this question, or this question can be done in a jiffy. But to understand the shortcut, we have to do this question stepwise. Okay, are you onboarded for stepwise? Then I will give you like quick solution for this question. Okay, so first of all, what we want is, let me just list down the properties. The very first property is adjoint of KA. Right here, there is no determinant involved. So K, if I have to take out from the, I want this -4, -3. So whole agenda of this question is what? Tell me. I want this -4, -3, right? And this 3. These 3 values I want that to get out of at least the brackets. And then eventually we will take them out of determinant. So adjoint KA will become k raised to power n minus 1a. Order is 3. So this will become what? K square a. Onboarded with this idea? So -4 will come out of this adjoint. Okay. So it will be, -4 will be out. So -4 into some matrix is happening. So just think about this as a adjoint -4 and a separate matrix. Let's say B. Correct? So adjoint, so what is happening? Let us just write down adjoint of -4B. So this is actually going to become what? -4 square adjoint B. Right? So 16 adjoint B. Yes? Or you can write -4 only, because when we will apply the shortcut, now you will be unable to understand. -4 adjoint B. So this -4, if I just remove this -4 and take it out, so this will become, determinant is already there. I'm just taking out and I'm writing it after, like just before the adjoint. Understand? This -4, this k is coming out where exactly it is written. And this is actually adjoint A. So this k is coming out power n minus 1, but that's just before adjoint. So -4 square. Now adjoint. Okay, 2 adjoints are together. We want all the adjoints together without any interruption. These are interruptions. Okay, adjoint. Now -3 adjoint, 3 adjoint, 2A inverse as it is. Correct? Now I want this -3 to come out. So if -3 will come out, now it will be written over here right before its previous adjoint, and this will become what? 3 square. -3 square, right? -3 square. So let's do that. So this is -4 square adjoint, and this will come over here. So you have to write -3 square, right? Then you have adjoint. Okay, so this -3 is gone. So this is here. Okay, this is written over here. So how many adjoint? 1, 2, 3, 4. Adjoint. And so this interruption is gone. Now 3 adjoint, 2 inverse. Just count the number of adjoints. 1, 2, 3, 4. Total 4 now. 1, 2, 3, 4. 4 total, right? Oops, now can you see this? Are you serious? This -3 square is again stuck over here. So I have to take this over here. So this is going to be minus 4 ka square. Now minus 3 ka square is already here. If I have to push this over here one more time, I have to apply the property. So minus 3 ka square, one more square. So minus 3 raised to power 4. Okay, now can you see it? 3 adjoints at least are together. Adjoint, adjoint, adjoint. Now there is one interruption. This is adjoint 2a minus 1. Okay. Now this 3 you want to get, now you know the drill, right? So this 3 will come here. Now it will become 3 square. This 3 will come here. 3 square ka square. So 3 raised to power 4. 3 raised to power 4 will come here. 3 raised to power 4 square will become 3 raised to power 4 to the 8. So now you are having minus 4 ka square, minus 3 ka square, and 3 ka power 8. And you are having so many adjoint, 4 adjoint, 4. Adjoint, adjoint, 2a, and this inverse is here. Okay, bracket close. Now you actually yourself know the shortcut. Now just calculate this, no? Final calculation. So this is 2 raised to power 4, 3 raised to power 12, correct? Then we are having adjoint, 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 2a inverse. You know which formula I'm going to apply? Determinant close. Let me just go back and tell you. I told you that this property, yes. Can you see this? 4 times, this multiple times adjoint. So, if 4 times it is written 4 times, tell me what will happen. Determinant of 4 times adjoint, adjoint A. So, it will become equal to determinant A raised to power n minus 1. N is the order. So, 3 minus 1, 2. Raised to power how many times? 4 times. So, this is going to be determinant A raised to power 2 raised to power 4. Okay. So, yes, this is the formula which we are going to apply. Okay, but before that, I have to take this also out. Please understand. For that, one more property. Determinant of Ka. Remember, again, I have to take this constant out, but I have to pay the maximum price. So this 2 raised to power 4 and 3 raised to power 12 will come out. So 2 raised to power 4, 3 raised to power 12. Order is 3, so that's why 3. Now we are having 4 adjoint over here. And this is 2 raised to a inverse. Finally, this is 2 raised to power 4, 3s are 12. 3 raised to power 36. And we are having 4 times adjoint. So you know that 4 times adjoint. So determinant 2a inverse is already here. Power will be n minus 1 raised to power k. 3 minus 1, 2 raised to power 4. Okay. So this is 2 raised to power 12. 3 raised to power 36. 2a inverse ka determinant is there. And the power is 2 raised to power 4. So that is going to be 16. This is 2 raised to power m, 2 raised to power n. Correct? Okay, and m plus 2n is what? 3 raised to power n. M plus what we need to calculate is 2n. We are very close, very close. 2 raised to power 12, 3 raised to power 36. You know which property, right? This is minus 1 is here, whole. So determinant of B inverse is 1 upon determinant B. So determinant of 2A inverse, the power you have to understand. The power is on complete 2A inverse. That's why 1 upon 2A raised to power 16. And now one more time we have to, can you see so many times we have to apply the same property. 2 will come out. And that is going to be 2 cube power 16 is already there. So 2 cube power 16 determinant A raised to power 16 is 2 raised to power n. Now determinant A you already know given as 3. So this is going to be 2 raised to power 12, 3 raised to power 36. This is 2 raised to power 48 and 3 raised to power 16. So this is going to be 2 raised to power minus 36. Okay. 3 raised to power 20. So m is plus 20. M is minus 36. N is 20. If you go and put the value over here, so minus 36 plus 40 will give you 4 as the final answer of this question. So yes, I agree that this is a beta question, right? Now you must be waiting for the shortcut, aren't you? Yes. So I will actually, so this screen you are seeing, it is like so many steps are involved. I will tell you the final shortcut of this thing over here. Let me just write determinant adjoint -4 -3, 3. Yes, now I know the, like, I have to remember. So adjoint of -4, adjoint of -3, adjoint of 3, adjoint of 2a power -1, correct? Whenever you see multiple adjoints, and you have to get, understand, you have to get rid of this, right? So 3 will come out, it will join this, it will become 3 square. Okay, so you just remove 3 and you write 3 square. Now this is -3 into 3 square, so you can write down this as, okay, so -3 into 3 square. Now this whole thing will be out of this, it will join -4, so it will become -3 into 3 square ka one more square, and so it will be written over here, so in multiplication with -4. And now the collective -4 -3 3 square whole square, it will come out like this, so it will become what? So -4 will become square, so this is finally -4 ka square. This -3 ka already square, now one more square, so -3 power 4, and 3 square ka square, 3 power 4 is already here, one more, so 3 raised to power square ka square is 8, and there is 4 times finally adjoint 2a inverse, and now this will come out, and we are going to use k cube property, Ka determinant, right? So this will be power cube. So -4 square ka cube, so 2 3s are 6, -3 4 3s are 12, 3 8 3s are 24, and 4 times adjoint is there 2a inverse. That is going to be 2 raised to power m, 3 raised to power n. And now you just have to proceed it similar way. So this is determinant 2a inverse. This is 2a inverse raised to power n minus 1. So 2 raised to power 4, 1 upon 2a, and this is 8. Now you just put the values. This we have done already. Now the shortcut, what is the shortcut? This step is the shortcut. After that, the method is exactly same. That we have already done. Okay. All right. Another similar type of a question. Okay, are we ready for it? This is the last question of this lot. After that, we will be solving system of linear equations. All right. So now we are having this. Let A be a non-singular matrix of order 3. Okay, again order 3. Determinant of 3, adjoint of, okay, then we are having 2 adjoint of, then we are having determinant A and A. Okay, that's it. So yes, this is the previous shortcut which we are going to use it right away. Previous shortcut, can you remember? We are going to use that. Okay, so this question is much simpler than the previous question. Okay, so if you are scared ki abhi to or now to I will not be able to solve, there was only one like beta question, right? This is actually easy. Now this 2, if you have to take it out, this is 2 square. You know the shortcut. If you want to take 1 2 out of the adjoint, 2 square. For the order 3, obviously. 3 multiply 2 square, and this is adjoint determinant A. Okay. 3 2 square. So this is 4 3s are 12, right? This is 12. So 12 is stuck inside the determinant. So this is 12 cube determinant A. So this is actually 12 cube and adjoint of determinant A into A, bracket close, one more bracket close, and this is 3 raised to power minus 13 and 2 raised to power minus 10. Okay, this is 12 cube. Okay, but again we have to do this everything in terms of 2 and 3. Okay. Now adjoint of anything, let us mark it as C or B. So determinant of adjoint of B, tell me the property. Ma'am, determinant B raised to power n minus 1, so 2, and how many times? 2 times, so square. So determinant B raised to power 4. So this is determinant of determinant A raised to power 4, and this is 2 raised to power 6, correct? Because 2 square, 4 3s are 12, 2 square and 3, correct, and 3 cube. And now here you have to apply your brains. This is actually tricky. Now tell me, determinant A is a constant value, right? Determinant A you don't even know, but that is a constant value. So this will be like tackled as K. So this is actually determinant of Ka, that is written as determinant Ka. So K will come out. It will be K cube determinant A. So this will be 2 raised to power 6, 3 cube. This is K, so K cube raised to power 4 is already there. Let's not forget. Okay, I'm just talking about this. So it will come out K cube. So this is K cube determinant A power 4 is already there. Okay, here there are high chance of making mistake. If you are not understanding, do it step by step, right? Multiple times, then only you will be able to understand. Now K raised to power, K is what? Determinant A. So K raised to power 12, that means determinant A raised to power 12, determinant A raised to power 4, this is 3 raised to power minus 13, 2 raised to power minus 10, correct? If you solve it out now, so determinant A raised to power 16 you are going to get, which is, this is 3 raised to power minus 16, and again 2 raised to power also minus 16. Can you see? If you shift this towards the right hand side, determinant A raised to power 16 is 1 upon 6 raised to power 16. So determinant A is nothing but plus minus 1 by 6. Huh. Okay. And now, this very small thing we need to solve to get the value of M and N. So this is determinant of 3 adjoint to A. And that is going to be 2 raised to power M, 3 raised to power N. Trust me. These type of problems are very popular. You are seeing yourself, right? This is the type where JEE Main ask. So if you say I'm gonna leave this and I want to focus on rest of matrices and determinant, not happening. You are here to gain the marks also, right? Nobody is giving you award. Ki acha, you know rest of your matrices and determinants concepts are clear, but this is you're not able to do it. So just face it off. Do it. Like once you start doing it now, then you will realize this is actually not at all difficult. It's just that you have to recur. You wanted like 5 to 10 good questions, good practice questions. Now this 3, so this 2 will come out, it will join 3, 2 square. So 3 into 2 square adjoint of A. Now this will come out and it will become cube. So 3 dot 2 square and cube adjoint of A. Adjoint of A, you know, that is going to be determinant A square. This is 3 cube 2 raised to power 6. This is 3 cube 2 raised to power 6, and this is determinant A square is what? 1 by 6. So 1 by 6 square. 1 by 6 square is basically this. So this is 3 cube 2 raised to power 6, 2 square, 3 square. So this is 3 raised to power 1, 2 raised to power 4, right? So M is your 4, N is your 1. Easy peasy. This question, come on. 4 and 1, right? So 4 and 1, 3 4s are 12 plus 2 1s are 2. 14 is the correct answer of, ignore this. 14 is the correct answer of this particular question. All right. So we are done with all the questions that were related to properties of adjoint, properties of inverse, all the properties, and I have listed all the properties also. Now it's your job to do all the questions one more time and try attempting January attempt questions as well, and then watch my January attempt video as well. Okay, so now let's start with system of linear equations. One question short you're going to get, system of linear equations. And I have taught this in my roar series. I have taken a separate session for system of linear equations, Cramer's law. If you have not watched it, what are you waiting for? Go and watch it. Okay. So let's see what this question has to say. So very clearly they are saying that the system of linear equation having m and n unknown has infinitely many solution. Okay. And here we need to figure out the value of m and n. Once we are done with that, we need to figure out which of the following 4 options is correct. Okay. So infinitely many solution, what is the condition of infinite many solution? For the condition is all 4 determinants should be equal to 0. Okay. So all 4 determinants should be equal to 0, and I'm not even kidding. You just see that in April attempt, how many questions from this particular topic alone was there in your April attempt? Yeah, so this is the very first question. Now we are having another question of infinitely many solution, the second question, all right. Then we are having third question, again same infinitely many solution. Then we are having again fourth question, without even blink. They are not even giving unique or no solution, infinitely many solution. Fourth question, then fifth question same. Okay, then okay, then this is a different sixth question, but from same Cramer's rule. So sixth question alone from April attempt. Okay, and by the way, one more question was that is also from Cramer's law, seventh question. Okay, with a little bit of variation, but this is also from the seventh question straight from Cramer's rule, and there was 10 question papers. What does that mean? 7 out of 10 paper were having this particular problem. Okay, all right, yes. So yes, same method, same technique, different numbers, different unknowns. Just solve it out. So delta, all the delta is 0, but we need only 2 values. We just need m and n. So for that, we just need 2 equations. That's it, 2 unknown, 2 equation. The very first thing is what we need to do is delta should be equal to 0. This is first thing what I'm going to do. Let us quickly do that. So let us create the primary determinant delta. So 1, 1, 1, 2, 5, 5, 1, 2 and m. 1, 1, 1, 2, 5, 5, and the last row is 1, 2, m. Correct? If you open it, this is 0 for infinitely many solution. If you open it, you know what do you get? You will get the value of m, right? So this is going to be 1, 5m minus 10 minus 1. Then we are having 2m minus 5. Correct? And then we are having plus 1. And we are having 2 to the 4 minus 5, correct? This is going to be equal to 0. This is 3m, correct? And minus 10 plus 5 is minus 5. And we are having minus 1. So clearly m is nothing but 2. Yes, m is coming out. M is done. Similar case, we need to figure out the value of n. So out of these 3 determinants, now del x, del y, del z, you have to pick one and make it 0. Now you would be wiser if you pick del z 0. Otherwise, like if you pick del x, del y, it's fine. But if you pick del z also, no, then also it's fine. So del z, if I'll do it 0, and del to I have already done. So these two will help you a lot. Okay, del z. So that means that in del z, what do? First column remains same. Second column remains also same. What you have to change is the very third column, 417n. So you have to replace that 1, 5 and m, column number 3, by 417 and n. So this is going to be replaced by 417 and n, make it equals to 0. Right? So here there is only one unknown, n. That's why I said ki replace this column. Right? Because this is having the unknown one. Del z will be equals to, tell me, 5n minus 34 minus 1. 2n minus 17 plus 4. 2 to the 4 minus 5, so minus 1 equals to 0. So this is 3n. Then we are having minus 34 plus 17. So that will give you minus 17, and this is minus 4. Minus 17 and minus 4 is equals to 0. N is clearly 7. M is 2. and n is 7, right? M is 2, n is 7. M is 2, n is 7. Okay, all right. 2 and 7. So 4, option 1 I am checking. 4 plus 49 minus 2 minus 7. So that is going to be, this is your 40 plus 4, 44. So this is 44. Option 1 is wrong. Okay. Again, 4 plus 49 plus 7 to the 14. So it will give you 49 plus 4 is 53. 53 plus 14 is 67. Correct? So this is also wrong. Then 4 plus 49 plus 2 plus 7. Right? 49 plus 4 is 53 plus 9. 53 plus 9 is 62. Again, this is correct. So, fourth option should be, better be correct. Fourth option is, I'm not able to see, just give me, m square plus n square minus mn. Okay. So, 4 square, 2 square plus 49 minus 14. Correct? So 4 minus 14 is what? Tell me. So 49 minus 10 is 39. Obviously, option D or option 4 is absolutely right. Okay. So this is how we need to do. Just tell me one thing. Infinitely many solution, not at all that difficult. What do you think? Okay. So let us now talk about the very next question on our screen. Okay. Which is this. If the system of equations having infinitely many solution, again the same category question, all like del is equals to del x equals to del y equals to del z equals to 0. Okay, so let us start with del. Tell me what is del. So 11 1 lambda, correct? Then 2 3 5, and then last is 8 minus 19 minus 39. This is 0. This will give you what? The value of lambda, right? Let us expand it right away. Or if you want to apply the properties also, then also it's fine. Okay, but I feel that I can expand it right away. 11, 3 into minus 39. This minus this minus this, right? So it is going to become 3 into minus 39 and plus 19 into 5. Plus 19 into 5. Minus 1. 2 dot minus 39. This cross this. Minus 40. Minus 40. Correct. Plus lambda times. And now we are having this cross this. So minus 19.2. And let me just write it on the next, plus lambda times, so it is going to become 2 into minus 19 and minus 8 3s are 24. This is going to be equal to 0. Correct? 11 is already there. 39 into 3, so 9 3s are 27, then 2 carry, 3 3s are 9, 10 11, minus 117 plus 9 5s are 45, 4, so 5 ones of 95, correct? Minus, now this, 39, 9, 7, minus 78, minus 40, correct? Plus lambda times, this is going to give you minus 38, minus 24 equals to 0, correct? Okay. Now this will become 11, right? Now 95 minus 117 will give you 17 plus 5, so minus 22. Minus minus plus 78 plus 14 is 118, correct? This is going to give you lambda and this is 50, not 50, 62. Okay, so 118 minus 242 is equals to lambda times 62. Calculations are actually not very easy. So 242 minus 118, 12 minus 8 is 4. 4 minus 1 is, actually 3 minus 1 is 2. 124. Okay, minus 124 upon 62 is the value of lambda. Did you notice actually it is coming out as minus 2? So lambda value we are getting, which is equals to minus 2. So this is minus 2 raised to power 4 minus mu. Now mu we have to calculate. Now to calculate mu, obviously del z, calculation of del z will be much more fruitful for us. So again column 1, column 2 in primary determinant del will be same. Okay, 8, so 11 to 8. Then 1, 3 and minus 19. And this is column 3 now will be replaced. So this is minus 5, 3 and mu. Let's solve it out. So 11, 3 mu minus, okay, plus 57, correct. Minus times, then 2 mu minus 24, correct. So 2 mu minus 24. Minus 5 and you are having minus 38 minus 24, correct. Minus 38 minus 24 and this is equals to 0. So 33 minus 2 is 31 mu, correct. 33 minus 2 is 31 mu. Then we are having 57 into 11. You know how to calculate anything multiplied by 11. So 7. Then 5 plus 7 is 12, 1 carry, then 5 plus 1 is 6, 627, correct? Then we are having plus 24, then we are having plus 5 multiply, this is going to be 62 equals to 0. So 31 mu is equals to 627 plus 24 and this is 100, okay, this is 310. So this is 1, this is 6, this is 9. So minus 961. So mu is nothing but minus 961 upon 31, which is going to give you what? So this is 31 ka square only, 961. So this is minus 31. So mu is minus 31. So minus 31 and now if I solve it, minus 2 raised to power 4 is 16 plus 31 will give you 47 as the absolutely right answer. Alright, okay, clear, perfect. Next question. So yes, I agree that the calculations, so there are chances of making mistake in the calculation, especially while giving the mock test or JEE Main actual paper. Otherwise, as a question, it is not that difficult. But in the exam temperament, just multiplication, division, these things, absolutely I agree. So that you have to build exam temperament. That's what we are doing. Okay. Now again, if the system of equations has infinitely many solutions. Now just tell me one thing, if I calculate, so again the same thing, del x, del y, del z, all four determinant for infinite many solution, this is the condition, should be equals to 0, right? All four determinant for infinite many solution is equals to 0. Now tell me if I talk about del now, del to it should definitely be 0. But in this question, if I talk about del, can you see the lambda and mu, both unknown quantities will be there present in your del equals to 0. So rather than actually talking about del, let me just do one thing, del x. Now if I pick del x, what will happen? This 3, 4, 1 minus 1 will be in place of these 2, 3 and 1. So again, I want the second column and I want the third column. Either second column should be free from mu or lambda or third. So del y and del z are should be the point of like solving, because all four we are anyway not going to solve. We just want our like lambda and mu to get found, right? So that's it. So we are not talking about del and del z, del x, because if you create del, you will see yourself that in the same determinant two unknowns are there. Same goes for del x, but for del y it is not going to happen. So how to calculate del y? For that, column 1 and 3 will be same. 2, 3, 1, right? This is column 1. This will be column 3, lambda, 5 and 32. But the middle, the column 2, 7 to mu instead of that. Because if I write 7 to mu, it will become del. I have to write 3, 4 and minus 1. Understood? This is equals to 0. That's it. Solve it out, okay? So 2, 4 2s are 8, 4 3s are 4 2s are 8, 4 3s are 12, right? 128 minus this plus 5 minus 3 times, okay, so 3 times 32 multiply 3, so 3 2s are 6, 3 3s are 9, 96 minus 5, okay, minus 5. Now plus lambda times minus 3 minus 7, okay, minus 3 minus 4 basically, that will become minus 7. Okay. So now we just have to calculate it, right? So 2 into 128 plus 5, so 2 into 133 minus 3 into 91, this will give you 7 lambda, correct? Now this is going to be 266 minus 273, this is going to be 7 lambda. So this is 4 minus 7 lambda. Okay, minus 7 is equals to 7 lambda. Here it gives us lambda is equals to minus 1, right? So from here lambda is coming out as minus 1. Now you have to check for del z. So right now you have got the value of lambda. So it doesn't matter if you calculate del x, del y, del z. But since we have decided del z, let's calculate del z only. For del z, what we need to do is column 1 will having 2, 3 and 1. Column 2 will be having 7, 2 and mu. Column 3, yes. Column 3, instead of lambda 5 and 32, although you can write because you know the value of lambda, but because we are calculating del z, 3, 4 and minus 1. Otherwise, it would have been del and that is also fine. No issues. Okay, so yeah, it looks good. The numbers are pretty small, so we can just expand it. 2 and this is minus 2, correct, minus 2 and minus 4 mu, correct, minus 7, then we are having minus 3 minus 4, okay, minus 3 minus 4 plus 3 and we are having 3 mu minus 2 equals to 0, correct, okay. So this is going to become minus 4 minus 8 mu, 7 7s are plus 49 plus 9 mu minus 6 equals to 0. So this is your mu and that is going to be equal to, plus mu is equals to 49 minus 10. So that is going to be minus 39. This is the value of your mu. Okay, now you have the value of lambda. Minus 1 minus minus 39. So this will give you minus 1 plus 39. 38 is the correct answer. So 38, bingo, 38. You've got your answer. 38 is absolutely right. Okay. All right. So now another question done nicely. And now we are heading towards our next question. Again, the similar thing we have to do. Infinitely many solutions. So if I see this mu is over here and where is my lambda? Lambda is here. So I guess we are pretty safe that if I calculate delta, you know, all 4 determinants should be 0. Now this time if I calculate delta, then also it's fine. So 1, 4 and minus 1 would be our first row. This is 1, 4 and minus 1, correct? 7, 9 and mu. Okay. And 5, 1 and 2. 5, 1 and 2. If you make it 0, then you will get the value of mu, okay. And now del x, if you take del z, you should take del z equals to 0. So del z may, the first 2 columns will be pretty same, okay. And the last column 3 will be replaced by lambda minus 3 and minus 1. All right, okay. So now I'm not going to solve this complete. What I'm going to do is I'm going to tell you the values of this question, right? Value of this question, mu plus 2 mu plus 3 lambda is what you need to calculate, right? So for this question, perfect. So from here, if you solve it, you will get the value of mu. I have the values with me. The value of mu is 0, okay. And if you solve it, you will get the value of lambda. Do it, okay. The value of lambda is going to become, I have the values with me, -1. Yes. Now the moment you put mu and lambda in here, what will you get is 2 times 0 plus 3 times -1. So that will give you -3. That is option B, or second option as the correct answer. Okay. And also I will, this is the last question on the similar pattern. Again, you are going to do that. Okay. So what we need to do is, yes. So clearly lambda is here and mu is here. So what you need to do is del equals to 0. First thing, and second will be del z equals to 0. If you mark del equals to 0, then 3, 5 and lambda. 3, 5 and lambda, 7, 11 and -9, 97, 155 and -189. That is, if you make it 0, you will get the value of lambda from here. Okay. Now what about del z? For del z, the first two columns are exactly copy pasted. Right, and the third column is replaced by 3, 2 and mu. So 3, 2 and mu. From here you are going to get the value of mu, right? So again, you are going to do that. The value of mu and lambda I have with me. So lambda is -341 by 31. You have to reduce the determinant by row and column operation over here. So lambda is equals to -341 by 31, and the mu is 1457 by 31. Okay, now if you plug in the value over here, so 1457 minus 682 upon 31. So the final answer of this question would be, just tell me, 5. Okay. Then, okay, 45 minus 145 minus 68. Right, 145 minus 68 will give you 45 plus 30, 75, 75, and 2 will give you 77. 775 upon 31. Yes, and if you cancel them out, 25. So option A is absolutely right. Okay, clear? So we are done with this as well, and now let's see what's in our plate. Again, another similar type of a question, but this is homogeneous. Yes, homogeneous system of equations, right? What is homogeneous? So whenever you see constant part 0, proper constant part 0, not the right hand side, because they can give you right hand side 0, but still constant part can be not 0. So just figure out, there is a term of x, yes ma'am, there is a term of y, there is a term of z, and there is no constant term available in all three equations. That you will call it as homogeneous equation. In that there are only two cases, just remember it. If you have to find a trivial solution, that means the condition for trivial solution, trivial means 0, 0, 0, that is unique solution. So delta not equals to 0, and non-trivial solution, this is reverse thing, non-trivial solution. That means basically infinite solution also you can say, delta equals to 0. Now you must be wondering, ma'am, okay, unique solution you have told us. Okay, infinite also you have told us. What about no solution? Just apply your brains and tell me that is that even possible that this equation is having no solution? Not at all, because 0, 0, 0 will always satisfy these type of equation. Homogeneous equation में 0, 0, 0 will always satisfy, right? That means there is no condition, it cannot be possible that it will have no solutions. Only two cases. For infinite many solutions, so we are to seeing all the determinants should be 0. So just remember this condition, and other condition is non-zero condition, that is unique trivial solution condition. Okay, let's solve it out. So 1 root 2 sine alpha, I am planning to create del x, and root 2 cos alpha, correct? Then 1 cos alpha sine alpha, correct? 1 sine alpha minus cos alpha is equal to 0. All right. Now just expand it and you're going to get it. 1 this cross this. So minus cos square alpha minus sine square alpha. Okay. Minus cos square alpha minus sine square alpha. Correct. Minus root 2 sine alpha. Now that minus cos alpha minus sin alpha. Okay, minus cos alpha minus sin alpha. Correct. Now plus root 2 cos alpha. So that will give you this cross this. Sin alpha minus cos alpha. Okay. So this bracket I need to remove. So this is sin alpha minus cos alpha. Correct. And this is going to become 0. Alright. So clearly this is going to become minus 1. So let me write it on here. Minus 1. Then go back. This is minus and this is also minus minus. Minus if I take out it will become plus. So root 2 sin alpha cos alpha. I'm multiplying, okay? And then root 2 sin alpha and so root 2 sin square alpha plus root 2 sin square alpha. Now next we are having plus 2 cos alpha. So root 2 cos alpha sin alpha. Root 2 cos alpha sin alpha minus root 2 cos alpha and one more cos alpha, so cos square alpha equals to 0. So these two can be clubbed together. Okay, and these two can be clubbed together. So minus 1 plus 2 root 2 sin alpha cos alpha, correct? And these two will become what? If you calculate, okay, so if you take minus root 2 common, then it will make sense. Why? Because it will become cos square alpha minus sin square alpha, and this is actually cos 2 alpha. So minus 1 plus this root 2 I am keeping it alone, and this 2 and sin alpha cos alpha. 2 sin alpha cos alpha is sin 2 alpha, and this is minus root 2, this is cos 2 alpha equals to 0. So clearly root 2, if I take common, sin 2 alpha minus cos 2 alpha is nothing but 1. So sin 2 alpha minus cos 2 alpha, it is coming out as 1 by root 2. Okay. Now this actually, if I just multiply 1 by root 2 here and here, both the sides, if I do that, what will I get? Tell me. So this can be written down as sin pi by 4, correct? This is cos pi by 4. Why am I doing that? Because this is going to be sin A sin B minus cos A cos B. If I take minus sign common, this is going to be minus of cos pi by 4 plus alpha, and this is 1 by 2. Minus sign if I remove and apply on the right hand side. So this is cos pi by 4 plus alpha equals to minus half. Now, okay, hold on. Alpha belongs to the very first quadrant. So cos of alpha plus pi by 4 is equals to what? Minus half. So you can write multiple things. For example, the very first angle 2 pi by 3 also you can write. Or you can write, that's it, 2 pi by 3. By the way, this is 2 alpha. Yes, so let's see it is making sense or not. Otherwise, I have to find another angle. Okay. So 2 alpha plus, so this is cos 2 pi by 3. Let's equate pi by 4 equals to 2 pi by 3. Okay. So 2 alpha is equals to 2 pi by 3 minus pi by 4. So this is 12. 4 2 is 8. 8 minus 3 is 5 pi by 12. So alpha is 5 pi by 24, which is very well belongs to the first quadrant. That means we don't have to like look here and there. 5 pi by 24 is definitely my answer, which is sitting in option D. Okay, all right. Okay, now 2 more questions to go and we are done with complete April attempt question. How are you feeling? Okay, so I would say that the last question is typical, like not proper beta. It is not consuming a lot of time, yes, but alpha plus, more than like you can categorize. So sometimes dekho, what happens is you must be wondering, ma'am, you defined clearly alpha and beta and now you every question you say alpha and beta. No, it's not that. So you have to figure out 6 easy questions, right? So that is how, like, it is already a relative thing. In one question paper, you have to identify the relative thing. That okay, between these 2 questions, you have to gauge the judgment. 6 to 8 questions you are looking for. So suppose 8 questions are done, then this question you can put in beta. But this, if like 5 questions only you are able to find out easy category mein. So you have to keep this question in alpha, right? Okay. So yes, because 1 minute is approximate. If you are taking 1 minute 20 seconds, nobody is going to like, there is no defined thing. But it should not go beyond like 1.5 minute or 1.7 minutes. It should not irritate you basically. It should not give you confidence. It should give you confidence booster basically. Okay, now this question. Okay, so this question is combination of system of equations plus definite integration. Combined question. Let's see what is the nature of this question, because this type of question is not very like popular, I would say, or like it is not roaming around in market. This is a new category of question. But again, even if it is a new category question, just understand that can I like what is given in the question, will I be able to solve it out? Okay. Let's do it out. Let's do it. Okay. Ax is equals to b has a negative solution. Okay, that is x is less than 0 and y is less than 0. Negative solution. Okay. And ax equals to b. So if you like form this equation, na, ax equals to b. So basically 2 minus 5, 3m. 2 equation, 2 unknown. Yeah, you don't need Cramer's law for that. You don't even need that, right? This is basic 2 equation, 2 unknown system of equations. Not unnecessary like matrices required. Just convert it. Row 1, column 1, 2x minus 5y equals to 20. First equation, 3x plus my equals to m. Second equation, right? Now the usual method of solving 2 equations, 2 unknown, that we are going to follow, and we are going to make use of both x and y should be negative. So calculate x, make it negative, calculate y, make it negative. Okay. And once you are done with that, then they are saying set of m is having interval of a comma b. So these two things will give you interval of m, and that is going to be a comma b. So from here you have to calculate the value of a and b, that is m belongs to something to something. And now a and b if you have calculated, right? So what you have to do is this determinant a value. Okay. Alright, let's do it. Let's understand. 2x minus 5y equals to 20. Let me write over here. And 3x plus my equals to m. Correct? How do you solve it? Okay, so it's very clear. Multiply 3 over here, multiply 2 over here. So this will be equivalent to 6x minus 15y equals to 60. Correct? 6x plus 2my equals to 2m. Now subtract. Okay, so subtract this minus this. If you do, you will get 2my plus 15y equals to 2m minus 60. Correct? So y will be equals to 2m minus 60 upon 2m plus 15. This is your y, which should be less than 0. That is the first thing. Now, what you're going to do is, in the very first equation, you want x also, na? In this equation, put the value of y. So you get the value of x. So 2x equals to 20 plus 5y. Correct? So 20 plus 5 times y. 2m minus 60 upon 2m plus 15. This is your 2x. So again, if you take LCM, 2m plus 15, this is going to become 40 plus 300 plus 5 to the 10m minus 300. 300 cancelling out. This is your 2. So 2x is equals to 40 plus 10m upon 2m plus 15. This 2, if you just put it over here, so this is also less than 0. Now you just have to solve it out. Okay, let's do that. 2m minus 60, 2m plus 15. Okay, so very easy. This is method of intervals. Plot the critical points. Minus 15 by 2 from the numerator, from the denominator, and from here you're going to get 30, right? correct? 30. This is your 2m, right? 2m minus 60. So negative, so minus 15 by 2 to 30, correct? All the calculations correct? And now this, x is what? Hold on, this is 40m. 40m. So 40m, so this is m. So this is 25m upon 2m plus 15 less than 0. So now again minus 15 by 2 to 0, right? Now this is your, when your x is less than 0. Now you have to take intersection of these two. Intersection, the moment you take intersection, it is very obvious. This says minus 15 by 2 to 30. This says minus 15 by 2 to 0. So finally, m belongs to minus 15 by 2 to 0. Now as per the question, m should belong to a comma b. So your a is minus 15 by 2 and your b is 0. Okay. And now what they are saying is you have to integrate. Okay. You have to integrate this. Okay. Let me just erase this part. This is already written on the right hand side. Already copy pasted. Now let us do that integration part over here. So determinant A you have to integrate. So what is determinant A? Tell me from here. Can you tell me? 2m plus 15 is your determinant A. So you have to integrate 8. Modulus, by the way, 2m plus 15 modulus of determinant from A to B. A is minus 15 by 2 and B is 0. Okay. So you can apply, you can just remove the modulus because you can remove the modulus and you know that the value will be anyway going to be the positive. Value should be positive. Okay. 2m plus 15. Okay. Let's see. So 2m plus 15 is equals to 0. M is equals to minus 15 by 2. So if you put any number below this, beyond this, you will get a negative point. And after this a positive. So you have to just open it with positive sign anyway, because between 0 and minus 15 by 2 you pick any number, you put it over here, you put minus 1, so this is going to become positive only. So 8 2m plus 15 ko you have to integrate now, and then you have to plug in the upper and lower limit. So this is going to be m square, basically 2m square by 2, 2 to cancel, plus 15m. Minus 15 by 2 is lower and this is upper. So now if you put upper limit, you are going to get 0. Minus, if you put lower limit, this is going to become 225 by 4 minus 15 into 15 by 2. Okay, so that is going to be 225 by 2. Correct? So finally 8 multiply. 225 if you take common, 1 by 4 minus 1 by 2 will be minus 1 by 4. So 225 upon 4. So this is gone and this is 450. Yes, so 450 is absolutely right. So this integration is very easy, but you have to be very careful, especially here. There you can do some minus plus mistake. There you can do some calculation mistake. So here you have to be very careful. So I will categorize this as beta question, because it requires a lot of like fursat, I can say, or relaxation while solving this question, especially while doing definite integration and when the lower limit is minus 15 by 2. है ना? Chalo, I would like to tell you one concept related to that. Let me just go over here. So the concept is that there is this shortcut of characteristic equation involving matrix. Suppose you are having a matrix A, B, C, D. Now you can directly write a matrix equation just by looking at it. I have taught you this in my determinants session also, row series, and I have made another video also, like the special shortcut. Okay, so if there is a 2 cross 2 matrix, now there is a shortcut. So a square minus trace of a times a, basically trace of a. So trace of a multiply a plus determinant a I equals to 0. So if you have that matrix, a square minus a plus d times matrix a plus determinant a is ad minus bc times identity matrix equals to 0. Just this I'm going to use it right away in this question. Okay, now let us understand the question first, and then let us understand where exactly it is happening. Okay, so b determinant is given to you, and there is another determinant a which is also a 2 cross 2 which satisfies these two given conditions. And now they are giving a polynomial equation in C, right? In C they are giving. Okay, so to actually get this polynomial equation in C now, we need to get the C matrix, because I have a slight feeling whenever the polynomial equation in any matrix is given, this is the concept. This is the only concept related to polynomial equation for a matrix. Okay. So C, I am after this C. If I have this C, this question would be a cakewalk for me. Okay. How to get C? Where is C, by the way? Except this, where is C? So ma'am, C is here. BC, B inverse. BC, B inverse equals to A. This is your C, right? Okay. So if you actually want to isolate this C, what you can do is, there are two ways to go about it. First, what I'm going to do is, in this pre-multiplication of B inverse, pre-multiply of B inverse and post-multiplication of B, because I want to remove this B and B inverse from, right? So BC, B inverse was already written, and on the right hand side A is already written. Okay, so now what I'm going to do is pre-multiply B inverse on the left hand side and same on the right hand side, post-multiply B on the left hand side and post-multiply B on the right hand side. So can you see B inverse B will become identity, B inverse B will become identity, C is coming out as B inverse AB, right? Okay. Now actually it is not getting created. From here I have some hint that C square, I am not looking after C, in fact I am looking after C square. So why not calculate C square, because right now I am not getting a final solution. Okay. Alright. So now let us multiply that pre and post thing. So B, C, B inverse is already there, A is already there. Now I'm gonna pre-multiply B inverse and post-multiply B. Same thing I'm gonna do on the right hand side. Why I'm doing that? Because I want to isolate this C. This is the only option I'm having. To remove B from the left hand side, I need to introduce B inverse. To remove B inverse from the right hand side, I need to introduce B. And can you see it is happening? This is identity, this is also identity. So ICI is B inverse AB. So C is nothing but B inverse AB. But can you see that this is actually not solving my problem? You know, this is not solving my problem. And also this A, what we can do is we can just put this A from this information. But again, right now we are not having A. So why not do we do one thing? Let's take inverse of this from both the sides. So AB inverse is already there, right? AB inverse equals to A inverse. Now what I'm going to do is take inverse both the sides, inverse and inverse. So right hand side is pretty simple. It will become A. What about the left hand side? Do you remember inverse always follow reversal law. So it is always B inverse ka inverse and then A inverse. So this is B A inverse equals to A, right? So this is B inverse. This is your A. A is B A inverse and B. So again, this is A inverse B. Correct? So C is A inverse B basically. C is nothing but A inverse B. Alright, okay, so till now actually I'm not getting any straightforward thing over here till now also. So now the next thing is, if I observe this carefully, this is C raised to power 4, this is C square. So I am not interested in C. Actually, if you look at it carefully, I'm interested in C square. So rather than like calculating this, what I should do is, I should actually stick to this and calculate C square from here. How to calculate C square? Writing C 2 times, that's it. So B inverse AB, this is your C. One more time, B inverse AB. This is making more sense, right? So now again, B and B inverse will become identity. So this is B inverse A, one more A and B. Okay, and now this same thing, using this thing, now A will be replaced by B A inverse. So B inverse, then B A inverse. Just because of this A, one A is kept constant, this is B. Now tell me, B inverse and B is identity, A inverse and A is also identity. Only B is lefting out, so C square is equals to B. Okay, C square is B. So this, if I replace it now, what will I get is C square plus alpha C plus B square. I am replacing C square by B. So B square plus alpha B plus beta I equals to 0. So this is a polynomial in B, right? Matrix B, and you know how to calculate it, right? Okay, so I know how to calculate a polynomial in B. I just taught you that. Okay, let me just go back. So here you have to write trace of A and here determinant of A. So going back will give me B square minus trace of A times B plus determinant B times I equals to 0. Let us plug in the value. Trace of B, tell me 1 plus 5 is your trace of B, so 6. Okay, and here determinant of B is what? This is your trace of A, trace of B. This is your determinant of B. So 5 minus 3 is 2. Now you compare. Clearly minus 6 is the coefficient of B and alpha is the coefficient of B. So alpha is minus 6 and beta, which is written in front of identity matrix, is 2. Minus 6 comma 2. So 2 into 2 minus of minus 6 plus 6 plus 4, 10 is the correct answer of this question. And with this question, we are done with all the questions of April attempt. Congratulations. It should give you a confidence booster that you have not even just completed it, you have just done it very nicely till you get the final answer. This is how you should do PYQs. It should get straight to your brain. And if in any question you felt ki ma'am, in this question I didn't get any confidence, you know what to do, right? This is Ninja Ma'am tip. This is a very basic tip, very fundamental tip, that the moment you feel underconfident in any question, if there is even 1% chance of like thinking that okay, maybe or may not be, I have understood this question, repeat it. The moment you repeat that question, that confidence will get skyrocketed, and JEE Main Maths paper is all about confidence, trust me. Okay, so now let us check another question on your screen is this AR. So determinant AR is given by this thing and we are looking for 2A10 minus A8, right? So 2A10. So first of all, let's calculate A10. For that, what you have to do is, if you carefully look at this determinant, so A10 is you will obtain when you put R is equals to 10 and A8 you will obtain when you put R is equals to 8. So 10 let's put, so if I put 10, it is 10, 20 and what about this? 8 3s are 24 minus 2, sorry 30 minus 2, 28, right? We are putting 10. So 10, 20 and 28. So 10, 20 and 28, the very first column. The next two columns will be copy pasted, 1, 2, 3, and n square plus alpha, n square by 2 plus alpha, right? Then we are having n square minus beta. Okay, then n, 3n minus 1 by 2. Correct? Okay, determinant close. And same, A8 if you want to calculate, then the next two columns will be same, exactly copy pasted, right? And the very first column, so r is equals to 8, 8, 16, 8 3s are 24 minus 2, 22. So 8, 16 and 22. To open it, I have to apply some row and column operations in both the things. So first let's focus on A10, right? So clearly this is 10, this is 1. So I want to check the column number 1. I want to change the column number 1, yes. Or column number 2 also we can do that. But C1 goes to C1 minus C2. Not C2 exactly, 10 times C2. Right, so I'm going to multiply 10 in column basically 2 and then subtract it with column number 1. So 10 minus 10 will give you 0. 20 minus, this is also multiplied with 10. So this is also 0. 28 minus 30 will become minus 2. Okay. So mission is actually successful because can you see two elements of single column became 0. So opening of this will become, expanding of this will become very, very easy. A10 key. Okay. So just that 2 key along, so minus 2 was there. This cross this. So n square minus beta plus 2 say if you multiply, so n square plus 2 alpha. So, sorry, this is minus, right? Minus. Yes. N square and n square is getting cancelled out. So minus 2 minus beta minus 2 alpha. So this is 4 alpha plus 2 beta. Similar thing we are going to do it over here. So now which column operation? Same. C1 goes to C1 minus this time 8C1, 8C2. So your A8 will become what? Tell me. This is 0 because you are multiplying the column number 2 by 8. So 8 minus 8, 0. 16 minus 8 is also 0. 22 minus 24. So minus 2. Okay, 1, 2, 3, 24, right? Minus 2 and 3s are 24, 2s are 16, correct. Can you see the same determinant is getting formed, right? A10 and A8 are same. Can you see? Can you see? I don't even have to write. A10 and A8 both are same, which is 4 alpha plus 2 beta. So this is actually 2A10 minus A8 ki jagah I am writing A10. So this is also A10 because, right? So this is A10 only. Hai na? So A10 value will be what? Tell me. 4 alpha plus 2 beta is the final answer, which is matching with option A. So 4 alpha plus 2 beta is absolutely right. Okay, all right. Let us move on to the next problem, which is combination of, matrices plus hyperbola. And if you carefully observe, this is from the topic characteristic polynomials. So the first half is saying that there is a matrix A of order 2, determinant A is already given, sum of diagonal is already given, and which is satisfying this polynomial. So the first half of question is actually directly spoon-fed. If you know that shortcut, that ninja shortcut, right? So A square minus trace of A multiply A matrix minus plus determinant A times I equals to 0, right? Sum of diagonal, that is trace, is minus 3. So A square plus 3A minus plus 3A plus determinant. What is the value of determinant? Plus 2I is equals to 0. Now you have to match this with this. Compare. On comparing, clearly x and 3 are equal. y and 2 are equal, right? Now the next half is all about hyperbola. So this is actually not a good, like, this is a bonus question from JEE Main April attempt 2024. So you can just ignore the hyperbola part of it because that was a bonus question. There was some error in this question. For now, you just can clear your concept that x is 3, y is 2, that's it. Okay. So this is also done. The concept is clear, I guess. Characteristic polynomial, especially the shortcut part. And now one more question. Okay. Same. So I have categorized the questions basically. A be a 2 cross 2 symmetric matrix which is given to us such that that 2 cross 2 matrix follow this particular condition. So first of all, let us form a symmetric matrix. You know how to form a 2 cross 2 symmetric matrix? So basically diagonal, if you want to keep A and D, let's keep the diagonal. And the non-diagonal elements are exactly same. So B and B. Yes, this is how you calculate, like you form a symmetric matrix. Right? Diagonal and non-diagonal. Non-diagonal will be nahi. So I will say conjugate elements. So A12 will be equals to A21 in symmetric matrix. Right? Aij is equals to Aji. And here we are having only single pair of conjugate elements because this is a 2 cross 2. In 3 cross 3, there will be multiple A31, A13, right? A12, A21 and A32, A23 like that. But here only one pair is there. Okay, so B and B are same. Okay, so let's take this and now put this value of A over here. So AB and BD. And again, can you see we have to form a polynomial over here? If you're not able to see, let me show you. Multiply A over here, you will realize. If I multiply A, what do I get? A. So if I multiply A, I'll get I because A into I, A inverse is I is equals to alpha A. So again, multiplying A over here. So alpha A squared, did you now notice? Plus beta A. So this is a polynomial, right? Okay. So to get the polynomial, I need trace and I need determinant value. For that, I need to solve this equation which is given to us. Correct? AB, this is your row 1, this is your column 1. So A plus B is 3, B plus D is 7. All right. Okay, A plus B is 3, B plus D is 7. And what we want is, what exactly we want? To form a like polynomial A square minus trace of A. So in this case, trace of A is A plus D, correct? Plus determinant A, AD minus B square is what I want. So I need A plus D and AD minus B square, correct? Okay. A plus D. All right. Determinant of A is actually already given. This value is already given. Did you notice? Determinant of A is 1. So that means AD minus B square is already 1. Now we can make good use of it. What we can do is calculate A in terms of calculate A in terms of B. Calculate everything in terms of B. Can I do that? So A will be replaced by 3 minus B. Correct? D will be replaced by, from the second equation, 7 minus B. And this is minus B square equals to 1. This is very easy actually. So this is B square minus 10B plus 21 minus B square equals to 1. B square gone. Minus 10B is equals to minus 20. So B is coming out as 2. The moment you get B is equals to 2, now you get everything, right? The moment you get B2, so A over here will become 1, right? And D over here will be 7 minus 2, that is 5. A and D are 5. So 1 and 5 basically. Now you know everything, right? So A square minus 5A plus this is your already 1. So 1 times I, right? This is 1 times I equals to 0. This is your polynomial, right? And now you have to compare it with this polynomial. Let me just go back. What polynomial we have obtained? A square minus 5A plus 1I. So plus I equals to 0. And what they are giving in the question is A inverse is equals to alpha times A plus beta I, correct? Alpha A plus beta I. So what we need to do is either take A inverse of this or multiply A into this and then compare. So let's do that. Anything will work. So multiply A in that. Okay, so that is going to give you I equals to alpha A square plus beta A. So identity value ka you have to calculate. So I from here is minus A square plus 5I. Now you compare this with this. So alpha is clearly minus 1 and beta is your 5. So what you have to calculate in this question is alpha plus beta, I guess. Okay, alpha plus beta is 5 minus 4. 5 minus 1, that is 4. So 4 is the correct answer of this particular question. 4 is the correct answer of this question. Okay. So now this is the final last question over here, and all right, so this is a 3 cross 3 matrix and this is a cubic polynomial in that matrix. Okay. Now what we have to do is we have to find the value of A and B. So A is here, B is here. Okay. So again, the traditional method of doing it is just like characteristic polynomial, A minus lambda I equals to 0 and all that. But we have a shortcut. How to form a cubic polynomial based out of a 3 cross 3 determinant. So the shortcut says that the cubic polynomial is A cube minus trace of A times A square plus some constant Ka minus determinant Ai equals to 0. The same similar type of shortcut is there in 3 cross 3 as well. It's just that we are here, we can identify the coefficient of A square and the coefficient of identity matrix. We cannot identify this constant K. So we cannot identify the complete cubic polynomial, but we can just get two values. If we compare, we can get A and B value. Let me show you how. So this is your cubic polynomial, and one cubic polynomial is already given. So A cube minus 4A square. Let's shift everything towards left hand side. Plus A plus 21I equals to 0. Now if you compare clearly, trace of A should be equals to 4. Trace of A is what? Sum of diagonals, right? So trace of A should be equals to 4. Sum of diagonals should be equal to 4. 2 plus 3 plus B. So 5 plus B is your 4. B is nothing but minus 1. Okay. Now what you can do is this 21 can be equals to minus of determinant A, or determinant A will be equals to minus 21. You can apply this very well. So let's find out determinant A in terms of A and B. Actually we are done, right? We know B and now we just need to know A. Right? Let's open it, expand it along the row number 1. So 2, 3B minus 5. Correct. Minus A, and you are going to have B, that's it, equals to minus 21. Now B value you can put it right away, which is minus 1. So this is 2 minus 8 and plus A is equals to minus 21. 8 2s are 16. So A is equals to 16 minus 21, which is going to be minus 5. A is minus 5 and B is minus 1, both are negative. Okay. So 2 times minus 5 plus 3 times minus 1 will give you minus 10 and minus 3. So minus 13, option D is absolutely right. So we are done with today's session. Okay, and let me tell you that if you want to connect with me in case of any doubts, any confusion regarding anything, this session or the other session, please reach out to me at namrata.jsinghani t.me/. Just confirm the slash is front slash or backslash. Okay, t.me/namrata.jsinghani. And also if you want to solve more PYQs, please do purchase our Tattva book. Tattva book link is given in the description box. So if I talk about Tattva book, it will have so many practice problems of previous year questions also. So basically, if you want to solve more problems, for example 2023, and that you have to do, right? And if you're looking for good source of error-free solutions, then we have a Tattva book for you, both for mains and advanced. right? And the link is given in the description box. Okay, so you can just go and check it out. Do like the session, and also next what you want to see in like this series, what do you want to see in next, what chapter you want to see next, you can just drop a comment and I'll upload that video. This is me, Namrata, signing off. I'll see you all in next video.